We're using a formula y minus b plus k over 2 equals 1 over 2 times the quantity b minus k times the quantity x minus a squared for parabolas. And again, we're looking for a vertex, a focus, and a directrix. If we can find A and B, we've got the focus. If we can find K, we've got the directrix. And if we get the equation in the right form, we'll have the vertex. So let's pound on this equation a bit. I've got a complete square in this formula, so I need a complete square in this equation so I can compare the two. So I'm going to isolate the x squared plus 6x. And to complete the square, I'm going to have to add something to both sides. Do you remember what we add? Yeah, half of b squared. So half of b would be 3 squared is 9. The left side factors nicely to x plus 3 quantity squared. The right side's just 12y plus 36. I'm not quite there because this has just a 1y and I have a 12y here, and I don't want to see 12y, I want to see 1y. So let's divide both sides by 12. That'll give me, I'm going to turn this around too, so I'm going to put the y stuff on the left and the x stuff on the right, so it's like my equation in the top here. That'll give me y plus 3 is the same as 1/12 x plus 3 squared. So now I have an equation of my parabola that's in the form that I'm used to working with for identifying these vertexes, focuses, and directrix. I should be able to see the a value right here. What's the a value for this equation? Close. -3, yeah. So I know that the a value is -3, so that's the x-coordinate of my focus. It's also the x-coordinate of my vertex. I can go ahead and get the y value for my vertex too. It's sitting over here. I need to look here to get the y value. What's the y value of my vertex? It's also -3. It's also -3. To get the y value of my focus, I have to figure out b. And to get the directrix, I got to figure out k. So now I really need to work with this. So I'm going to make some space here. Looking at this, this 3 that's here, this 3 corresponds to this stuff that's right here, right? So the opposite of 3 should equal the opposite of b plus k over 2. So -3 will equal b plus k over 2. This 12 that's down here corresponds to this stuff that's down here in the equation, the 2 times b minus k. So 12 should equal 2 times b minus k. Looking at this first equation, if I multiply both sides by 2, I can get quickly to b plus k equals -6. The second equation, if I divide both sides by 2, I can get quickly to b minus k equals +6. From here, if I add the equations, I get 2b is equal to 0 or b is equal to 0. So now I know the b value that goes here, that's 0. And I know enough to find the k value, because if this b is 0, what does k have to be? -6. I've got everything. I got my vertex at -3, -3, my focus at -3, 0, and my directrix at y equals -6. Number 6, we've got to write an equation of a circle with a center at 5, -8, and a radius of 8. Actually, this one, if you know what you're doing, you just write your answer and you're done. So let's write the answer and then we'll talk about it. X minus 5 quantity squared plus y plus 8 quantity squared equals 64 is the right answer. Let's go ahead and talk about that. Any questions there? If you're struggling with this problem, you might want to remember that the general form of the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared, where the center is h comma k and the radius is r. Notice the opposites here, the opposite of h. So the opposite of 5 is negative 5. The opposite of k, the opposite of negative 8 is positive 8. That's really important that we notice the opposites that are going on here. Yep, so knowing that makes number 7 really easy. The center is at 4, 8 because we're just pulling opposites out of here. And the radius is at 4 because r squared is 16, so r would have to be 4. And we're done with number 7. Let's talk about that if we need to. All right, so we're going to find the foci of this ellipse. In order to do that, we need to find a value c. C squared for ellipses is equal to a squared minus b squared. For this problem, a squared is 36, b squared is 9. So c squared is equal to 27. C is equal to positive negative root 27, which simplifies to positive negative 3 root 3. Now we just have to figure out which kind of foci we're looking at. This problem has a larger value under y, which means it's going to have a major axis that's vertical. My foci will be points somewhere along this major axis. These are points where x is 0 and y is whatever I found for c. So my foci are at 0, comma, plus or minus 3 root 3. Done.
And if it was on the other way, it would be plus or minus 3 root 3.
Yeah, if the 36 was under the x squared and the 9 in the other place, you're right. It'd be plus or minus 3 root 3, comma 0. Be the other direction. An equation of ellipse. If we're writing an equation of ellipse, it has to have this format. It's going to look like this, right? If it's an ellipse, it's going to have that format. This thing's being shifted. The center's not at 0, 0. It's at negative 3, negative 5. So my x isn't just going to be x squared. It's going to be a shift squared. My y is not just y squared. It's being shifted also. X is shifted to the left 3, so I need to see an x plus 3 in here. Y is being shifted down 5, so I need to see a y plus 5 here.
Wait, did you say 3 in the x?
Yep.
Shh. Where would you be without me? You know what? I don't need that kind of sarcastic remark.
All right. This thing says that the major axis is 8 long. The minor axis is 4 long. So what that means is my ellipse has a major axis that's vertical. That's important too. My major axis is vertical. My minor axis is horizontal. When it says it's 8 long, that means from top to bottom. So the value here from middle to end is only 4. When it says this is 4 long, that means from left to right. So this value is only 2. This 4 is my a value, right? I need to see a squared, or 16 somewhere. This 2 is my b value. I need to see 2 squared, or 4 somewhere, right? Since it's got a longer axis that's vertical, the bigger number has to go where?
On y.
Under y. So I'm going to see the 16 here. That's the 4 squared. I'm going to see the 4 here. That's the 2 squared. And there's my equation of that ellipse. We're done. We're going to graph this conic section. We know this conic section is a hyperbola, partially because this is the section on hyperbolas. But we should also know it because we see a 4x squared minus a 36y squared. So that's a hyperbola. I don't want to see it in this form because I don't know what to do with it with the 100 here. So what do I got to do? Divide everything by 100. So let's do that very carefully. If I divide 100 by 100, that's no slam. That's easy. If I divide these guys by 100, there's one little issue here. 36 and 100 didn't make nice numbers. 4 100ths reduces to what? So I got x squared over 25. That's nice. Minus, let's skip that for a little bit. 100 over 100 is 1, right? Let's do a little scratch work here. 36 over 100 reduces to 9/25. But notice how I have like 1/25. I have 1 over 25 for this first one I did. It's really nice and neat. I'd like to see this as 1 over something so that I can just write y squared over here. And I can identify a and b and go on. So what 9/25 is the same as 1 over what? One over what? I'm going to pause the video here so we can talk. I'm so surprised. What's the rule for dividing by a fraction? 1 divided by the fraction 25/9. What's the rule? Flip it over and multiply. If I flip over 25/9, that's 9/25. If I multiply it by 1, aren't I back here? 9/25. Let's look at a simpler one here. Really simpler one. 5 is the same as 1 over what?
5.
You tell me 5 is the same as 1/5? That doesn't make sense. 1/5. 5 is the same as 1 over 1/5, right? So 9/25 is the same as 1 over 25/9. Okay? It's just reciprocals. It's just reciprocals on some level here. So 25/9. Now we got to go to graph this thing. I need the vertex and I need A and B so I can find the asymptotes. So the vertex is going to be where and why?
I don't know.
Anybody know?
0,
Which number is bigger? 25. So my vertex is going to be along the x-axis, right? What value am I going to go out? 25 is going to be my a squared, right? So I'm going to go out to 5. I'm going to go out to 5 and back to -5. So I'm going to have a vertex point about right here and about right here, 5 and -5. So my a value is 5. What's my b value? Yeah, what's the square root of 25/9?
I'll look at 5/3.
5/3, thank you. It's just the square root of 25 over the square root of 9, 5 over 3. So if you remember, my asymptotes then have to be at the equation y equals plus or minus, there's 2 of them, b over a x. So over here, let's figure out what b over a is. What's 5/3 divided by 5? 1/3, thank you. 1/3. So y is equal to plus or minus 1/3 x. Those are my asymptotes. So let's plot those so I can sketch this thing. So I'm going to plot those in this color. So if I go up 1, I got to go over 3, right? So I'm going up 1. I'm going to use one grid mark. So up 1 and over 3. 1, 2, 3, right here. So it's also going to go. I can use grid marks. I can use values. I can use whatever I wish. I go up 1 and over 3. Be right. 1, 2, 3 right here, and there's also going to be one right here. So let's draw those asymptotes. Normally, if I was doing this by hand, I'd do dashed lines. I don't know how to make this software do a dashed line. In fact, I don't even want that line, but I'm just using what I have here available. It would just be dashed lines instead of solid if I'm doing this by hand. Those are my asymptotes. So my graph, when I sketch this thing, is going to approach those asymptotes. So it's going to come along like this and keep going out forever. And it's going to do the same thing down here, keep going out forever, and then the same thing on the left side. It's going to approach the asymptotes. Kind of looks parabolic out there. That's it. The reason you dash these is because they're just guidelines. You don't really think of that as part of the graph. I'll show you the computer-generated one here in a second. Here's the computer-generated model of that same graph.